Hi, this is Wes Simpson, founder of LearnIPVideo.com and one of the original founders of the Video Services Forum. I'm here today to introduce Andy Rayner, who is the Chief Technology Officer for Nevion. Andy's going to be talking with us today about some of the new developments in the specifications that are being created in the ST2110 WAN Activity Group. Take it away, Andy.
So, just kicking off and giving you a little bit of background for those of you that don't know me. I'm based in the UK, work for Nevion, have worked for Nevion for just coming up for 10 years. Prior to that, I spent 22 years working for the big British telco, British Telecom, and I headed up their broadcast television technology team. I'm based on the southeast coast in a town called Felixstowe, only about a mile from the sea in the UK. But today I'm further up north in the UK on a little visit to some relatives. So that's where I'm talking to you from this afternoon or today. Just one slide on Nevion in case you're not familiar with who we are, what we do. If not, why not? No, seriously. But so we have two main tenets of our solution space, VoIPath, which is media orchestration and management and control, and Virtuoso, which is fully flexible software-defined media processing functions. And those are two key tenets of lots of solutions that we're working on. We've got a very strategic relationship with Sony, with which we're also delivering a lot of solutions now as well. We're very proud to be sort of founding parts of many of the standards organizations and really passionate about standards and open standards. Our Virtuoso has been used as a reference node for several of the JTMN testing events. And also in the middle there, if you'd like a copy, do let me know. We have a book that we've been updating twice yearly for the last 4 years called From Baseband to IP to Virtualization. And it's really kind of, if you like, what I call our Bible of the IP media technology journey and what's current and up to date and new. So we'd love to share a copy of that with you if you'd like. So that's my little plug over. So what we're covering today, really, I want to give you a little bit of background as to why we're doing what we're doing in the 2110 over WAN work. I want to give you a kind of an update of where we've gone in the last 18 months since the work's been started. Talk about what's still worked on, what the outcome's going to be. Also, I'll indicate if you've got any specific things that you want to contribute, you know, it's still not too late to be part of VSF and to actually engage with that. And then finally, as with every presentation I give any of you, and those of you that have seen me be speaking before will know this is a regular invitation, a cup of tea I would love to invite you to when we're actually allowed to physically meet up again and actually talk to each other face to face. So that it highlighted green bit at the bottom of the screen there to enable effective transport of ST2110 media flows and associated control data across wide area networks in an interoperable manner. That's kind of the working statement of the group. And, you know, just to give you kind of a 3-sentence summary on that, basically, you know, ST2110 is, you know, a revolutionary IP-enabled you know, production format that we're rolling out globally now, and it's going to become the de facto way of interconnecting media equipment moving forward. And it's already gained traction, has become what I call business as usual. What we're still working on is what's the very best way, best practices for doing distributed production and sharing between locations. And that's what I'm going to unpack. And that's what we're trying to work on in this study group. So just to give you a little plug, there are actually 3 working groups, VSF activity groups, that have quite a lot of synergy in this space. So Wes, who you've just heard, is co-hosting with Rick Ackerman the RIST group, which is all about reliable internet transport for media flows, typically in an OTT internet-based rather than private wire connectivity. But there's quite a lot of techniques there that are obviously applicable to any form of media transport. There's the newly formed, only been going for a few weeks, ground to cloud, cloud to ground group, which John Mayott and myself are co-chairing. And that's all looking about the future of cloud media services and how we can have standardized interconnect, compute-friendly interconnect within the cloud, but also a standardized way of getting media flows to the cloud and back down from the cloud to the ground. And what's the, again, for interoperability and best practice. And the 2110 over WAN group is saying, whenever we want to connect any facilities up, what's the best practice on how to do it so we can guarantee interoperability. I'll unpack that as we go in the next few slides. So that's just a little slide to explain the ground to cloud, cloud to cloud, cloud to ground elements that I was just talking about briefly then. So what we're defining, if you look at that red downwards arrow on the right hand side of the screen, what we're trying to define is what happens on the WAN side of the interface from a facility. So, in terms of definitions, that's what we're looking to do. The green side there on the left is obviously referring to what's inside an IP facility. Now, by necessity of some of the stuff we're trying to tackle within the group, we're actually going green side as well and needing to define some tenets of operation or plus bits that need to happen within the facility. But basically our mandate is to define what needs to happen on the gateway, if you like, for us to have interoperability, so we can have multi-vendor interoperability at different ends of wide area connectivity. So again, most of you are probably uber familiar with this whole suite of standards here. The top two rows is the ever-growing, although I think it's slowed down a fair bit recently, ever-growing set of toolkits of the SMPTE ST 2110 suite. You'll be very familiar with the top row because that's kind of in use and has been in use for, I don't know, 3 years or so now, since we actually kind of cemented it and got it out there. I'm not going to unpack and explain what all of these are, just to highlight on the middle row, one or two different and slightly additions from the original toolkit, if you like. The first one on the left, in the middle, the compressed video. I was personally a tad skeptical when we started considering this within the SMPTE working group, but actually, as I unpack what we're doing within 2110 over WAN, you'll suddenly start to see that actually having compression of video essence within the 2110 toolkit is immensely useful when we've got, more precious bandwidth and more restricted bandwidth for wide area connectivity, as opposed to the, typically relatively unlimited bandwidth available within a facility. There's one or two other bits again, which I'm not going to unpack on that middle row, which are things that are for specific applications or to actually allow us to actually get faster lock, faster control and things like that. And then complementary to those first two rows, which are obviously data plane, media essence data plane definitions, the bottom row is all about how we control it. And actually, I mean, arguably the control plane bit has been running, largely speaking, a bit behind the data plane in terms of the way the standards were evolved, and the maturing of the control plane standards has been, a bit behind the maturing of the data plane essence-based flows, media flows that we've been describing earlier. But all of those at the bottom are some of the essential building block elements of the control plane that's been worked on within NMOS. And one very, very important part on the very left there at the bottom is the security suite, the security of what we do. And I'm going to keep coming back to that within this explanation of what we're looking at is very, very important. But if you like, this is the toolkit which we're kind of expecting to exist within the facilities that we're looking to interconnect. So we're not looking at defining any of this stuff within this working group. We're saying, we're expecting as things go, more and more facilities are going to be using these toolkits of data and control planes, and we want to actually interconnect them in a robust manner. This is the slide that one of my colleagues in Nevion produced, which I think is incredibly useful because it kind of gives you a snapshot summary of the different elements that we're considering here. So if you think, the IP facility is one thing, and largely speaking, you could consider that actually that's, in some ways, simplistically, that could be almost construed as simple as replacing SDI with IP. It's so much more than that because it's format agnostic and it's extensible and scalable. But there's lots of advantages with IP within a facility. But as soon as we start using IP in the wide area as well and interconnect and federate and share resources, people, real estate, equipment, processing between facilities over IP WAN infrastructure, then suddenly the advantage, the cost saving, the resource sharing, all of that stuff becomes so much more of an advantage. So leveraging IP advantage within a facility takes on a whole new meaning when we're actually able to do distributed production and federate different areas together. And it's that kind of federation and distribution that we're talking about in what we're doing here. And I guess this is just another view of the same thing, really, saying, we have these IP LAN islands, and now what we're actually saying is we want to connect them together, maintaining that production essence environment, as opposed to what I call the more traditional composite connectivity that's not necessarily essence based that 2110 is. If you want to understand 2110 essence and want some more tutorials on that, there's many of them online that we can point you to later. One example from a real deployment we're doing at the moment, which I think is just useful to give you some of the teas of the importance of this. This is an international, multi-country distributed production environment that we've been a significant part of both the data plane and control plane on within my organization. And what you can instantly see there is the concept of two good data centers that have all the resources, the processing, the compute, all the equipment, if you like, lots of remote sites that are dual honed into those robust and resilient data centers over dual honed resilient network connectivity. You can see also, therefore you've actually got the need to securely actually connect both those two resilient data centers together, but also the remote sites. This gives you an example of a real world application that demands what we're talking about here. So onto the point in task, the distributed production, and what the kind of use cases that we were seeing. So when we very originally started this group 18 months ago, we brainstormed what was needed, and the three kind of typical use cases that kept coming back to us as the key requirements. One is event remote production. So I actually want to produce something where my gallery, my production center is away from the actual event. So I need the connectivity to facilitate that. The next one there is intra-company facilities. So that's actually one company actually wanting to share resources with another company at a production essence level. And the bottom one there, which arguably should probably be in the middle in terms of sequencing if I'd thought about it, is intercompany facilities. So sorry, it is right. Intra-company is actually within the same company. I'm messing myself up here. The bottom one is between companies. Obviously, the bottom two have kind of potentially different security requirements, although if you're going into a wide area network anyway, you probably actually need to have pretty similar levels of robust security anyway, regardless of whether you're going to your company at the end or a third party organization. So what we've been looking at within the 2110 over WAN group is two key things. First of all, how we actually standardize how we transport the media essences, the individual video and audio flows and metadata, etc. Secondly, and arguably the more complex element, as we've been discovering in recent months, is how we actually federate and securely share the registration, discovery, and control of those resources in this environment. So those are the two key focuses of what we've been looking at. And when I talk about two locations, I just want to put this, this picture is just to say to them, this could be interconnecting two different campuses where you're actually doing shared production. It could be connecting a campus to a truck where you're actually doing an event. It could be connecting a campus to a cloud. It could be connecting a truck to a cloud. Whatever, it's the end destinations are not important here. It's how we do the data plane and how we do the control plane in a secure way and in as much of a plug and play manner whilst maintaining that security. Security is all important, and again, I'll keep coming back to that. So just really as a whistle stop before we actually jump into what we've defined, just to get you thinking about what's important and what's different within our facility and on the outside world potentially. So within our facility, what I call the green side on the left there. So this is typically likely to be, a 2110 facility with an NMOS control plane. So what we have is first of all, we have PTP timing. So everything is co-timed within that facility. We have a defined way of doing device discovery and control that's defined by NMOS, where ISO 4 defines the way devices register themselves. So they are then discoverable, and then ISO 5, which describes the way we control it. And then there's also, if you like, additional appended control edges from ISO 7 and ISO 8. And then obviously all the security surrounding that. So that device discovery and control under NMOS. You've then typically, again, just thinking about this, within an IP facility, got an agreed IP addressing scheme. So the way your IP addressing done is common, or is defined for within a facility. And typically, hopefully, you're using a control orchestration tool that's abstracting you from needing to write IP addresses anywhere, but you do need to actually, there will be an IP address scheme that's being brokered for your facility, either by a human, but hopefully by a computer system. You've typically got uncompressed essences running within the facility, and protection termination. By protection within facility, I mean typically 2022-7, which is the RTP layer spatial diversity, which we use to give that resilience, where each packet is merged at the far side. I'm not going to unpack all of the corollaries of those on the WAN side, but suffice it to say, once you go off your nice campus, almost all of those things are up for grabs potentially. So how you actually work through that is important. And some of the gateway functions that we need to have on the boundary address those in different ways. And specifically, we'll be looking at some elements of that as we move through. So I'd like to unpack where we've got to so far with the work. And as you'll have seen, again, I keep coming back to this data flows and then the control layer. So what I'm going to do is unpack the data plane. We actually started with the data plane because that's a relatively easy bit. So you rewind 18 months to when we started this work, and this is what we were looking at. So if we dive into the data plane, I'll unpack these nice and quickly and just go through to outline them. The first one is looking at flow protection, and the most obvious of everything here is to apply 2022-7, which is the RTP merge for spatial diversity, and apply that for the flows that we're carrying in the wide area network. 2022-7 has been used in almost every IP facility I've been involved in the last 4 or 5 years. I was surprised to see its absolute ubiquity as it's got to there, and certainly in many WAN applications that I've been part of over the last 10 years, we've been using 2022-7 in the WAN as well. So it's common sense for this to be happening. 2022-7 was originally defined as being for the 2022-suite, but there was a revision made to 2022-7 last year that expands its applicability to basically any RTP flow. So any RTP flow is now effectively spec'd as being protectable using 2022-7. And the very simple thing is, you're taking 2 routes, you're doing effectively an alignment based on the sequence number, the RTP sequence numbering, and then you're merging those packets. And the concept is, if you miss packets on either flow, the other one, you've got 100% redundancy in all the packets coming in, so you can miss some on either side, and you can still recover a completely holistic stream. Flow protection #2. So as you'll probably be aware, those of you that have been around for a while in the industry, within 2020-2022, we had defined FEC -1 and -5. -1 was for transport stream-based flows, and -5 is for uncompressed flows. What we've decided within this working group is to actually take a subset of the -5 FEC that's already been defined. I say a subset, 2 main things there. First of all, we're only doing one-dimensional column-only FEC, not the recursive 2-dimensional that's been spec'd in the some of the specifications. And we're also going to do a very constrained length, time, depth. That's the matrix size of packets that we're correcting. We're doing that to constrain it because the kind of impairments we expect to see don't need a large product, a large matrix, a large period of time to cover, but also we're trying to keep the latency low. You know, we're in these remote production environments, latency is very important, and obviously the more packets you're storing up to do error correction, the longer latency you're adding. And I'm going to come on to one or two comments about minimizing latency in just 1 second. Trunking essences. So one of the other things that came in as a requirement from the user stories was two requirements really that drove us to looking at trunking. One is common latency. Now, if you look at those flows there, you're probably familiar with the fact that the -20 is the video essence. Now, in a UHD flow, that could be typically 10 gigabits per second, that flow itself. If we consider the -30s that are further down there, those actually, if they were stereo audios, they're probably the order of 2 megabits per second. Obviously, if they're mono audios, 1 megabit per second. So we're talking about many decades lower in bandwidth there. And the -40, if that's just carrying closed captions or some other ancillary data, that could be at least 1 decade lower in bandwidth than the audio as well. So we're looking about massive differences in data rates of these flows. And if you just going back to the FEC that I was describing earlier, if we were to apply FEC to the individual essences here, then the period of that matrix that we use for the error correction would be proportional or inversely proportional to the data rates at which those flows are running, which means the ancillary data could be taking many tens or even hundreds of milliseconds to actually create an FEC matrix, whereas the -20 would be, the order of microseconds. So the concept of trunking, and I always have to say this very, very carefully for fear of being misheard, the concept is that we FEC the trunk, we FEC the trunk, not the individual elements, because then we leverage the benefit of a very high data rate trunk, and we can protect that, and there's a very low latency applied, and it's common. And then also, obviously, if we've trunked our flows together, then the service provider is not able to, unfortunately, differentially route the different flows in different ways. So we know that everything we're going to do is commonly routed. I'll come on to the other stuff in a minute on another slide. So just to unpack where we had got to, and we actually finished doing this work on the data plane about 9 months ago, but we haven't actually get as far as actually publishing a draft of what this is, because I was naively waiting for us to finish the control plane as well. But following discussions earlier this week within the activity group, we're going to try and get these data plane recommendations out as soon as we can. Basically, what we were trying to do was make the trunk look like RTP as well. And the concept with that is that all of those techniques I've just been talking about, the 2022-7, the 2022-5 with the constraints, etc., those protection mechanisms then can equally well be applied using the same toolkit, processing toolkit, to the trunk as to the essences. That's the concept. And GRE is a very standardized header that already is in existence. So the proposal that we've got on the table at the moment, although it's not obviously cemented because we haven't finished the draft, is that we use GRE with an RTP header, a GRE header. That also allows us to actually include other data types as well. And that leads me on to this slide, because one of the other user story requirements we had in from several people at the beginning of this work was saying actually they have other stuff other than 2110 essences from an event that they want to protect with -7 in the same way that we're protecting the essences. May sound slightly strange, especially as, I'm anticipating some of those other flows may be TCP anyway, which means they inherently have retransmission, etc. But anyway, we've taken that on board, and in using the GRE as a header, that means we can take in any either Ethernet or IP flows and actually encapsulate and wrap them in the same manner and subject them to the same protection mechanisms. Now, essence timing, for those of you that know me will know that timing is one of my passions. So just a reminder that one of the key elements of 2110 is the fact that when we acquire a frame of video or an audio sample, we're actually using a GNSS locked PTP reference that we're taking to form our RTP timestamp. So we are actually timing and grabbing the origination time of each of those samples, those video and audio samples, and any other metadata or panel presses or whatever other actions that are happening in real time. Now, for me and for the working of the optimum working of a 2110 ecosystem, we need to preserve that information. So this is a slide I've been using as part of my campaign for the last 3 years, I guess. It is that what's important here is that we need to preserve the information on origination time as we go through our production chain, so that when we get to our consume time or use time on the right hand side there, we are actually able to automatically reconcile the essences that have by necessity and design been through their own processing chains. So the video's been through one path, the audio's been through another path, etc., etc. We can reconcile them automatically using the RTP information because it retains the origination time. Now, why is that important to specifically revisit within this group? Well, there is some work that's been done recently in the revision, what we call the 1 year revision, although I think it's about 3 years in, of ST 211010. And that's actually encouraging people to actually preserve origination time, the sampling time, as we go through our processing chains. But what's very important here for this activity group is as we go out of a facility and onwards to another facility, it's really important that the relationships between the different related essences, media essences, are reconcilable downstream. So to that end, the two things we've actually said within the drafting that we've done so far on the data plane is that either there needs to be the essences that need to have been buffered so they are nominally time aligned, or at least / as well the RTP timestamps of each of the media flows that relate to each other, the media essences that relate to each other, need to actually, the RTP timestamps of those need to be relational and reflect the time offset between them. So coming back to the use of the RTP needs to reflect the differential time between the video and audio. There are some very valid reasons why you may not necessarily want to compensate and delay your audio as you egress a facility, because you know downstream the audio is going to be subject to some significant buffering as part of another process. So you don't want to add unnecessarily delay. So if you're not going to be aligning your flows on egress from your facility on this barrier on the right hand side, then what you do need to do is to at least make sure the timestamps represent the differential time between those essences so that they are reconcilable downstream. Compression, as I alluded to earlier, compression we're seeing as being important, and certainly from my perspective in my day job, we've actually started using JPEG XS very significantly in the last 12 months to compress LAN infrastructure as we go over WAN. So the 2110-22 is becoming incredibly important, simply because wide area bandwidth, sometimes nationally, but definitely internationally, is obviously relatively costly, and you're actually doing some very low latency, pristine compression to actually give significant bandwidth saving is important. There are other mappings into -22 which could equally well be used here as well, and I think we're going to unpack those as well. It's also worth saying that another thing that we haven't dabbled onto yet, but which has been a requirement, is just making some definitions of the interface integrity, because many people, of course, for many decades now have been very used to actually doing, if you like, baseband video analysis to define the integrity as we're either coming in or out of a facility. Now, of course, it's IP in and IP through. So we need to define the if you like, common boundary analysis and how that's defined to actually define integrity. Again, very simple stuff. We know all about effectively using sequence numbering to detect lost packets. We know how to use the timestamps to look for unacceptable packet delay variation, jitter within the flow, etc. It's no-brainer stuff, but we actually need to do it. So this is a quick summary here on this list of the conclusions of the data plane today. I haven't unpacked the MTU question, but just to talk about it for 30 seconds before we move to the control plane. The discussions on the MTU have been along the lines of, obviously, if we're doing any kind of further encapsulation, like the trunking I described earlier, then we're actually making the packets bigger, and therefore we have, risk of exceeding standard MTU sizes. Now, there's a couple of comments to that. First of all, with the typical video and audio 2110 essences, it's relatively straightforward for them to be defined. In fact, generally, they're not trying to max out their MTU anyway. So it's very typically, they're going to have the headroom, if you like, on packet length to actually add these headers without compromising MTU for non-jumbo friendly wide area connectivity. Obviously, wide area connectivity is getting better at supporting jumbo frames anyway, so it's becoming arguably less of an issue. The potential space where I think we're likely to see MTU issues more likely is in control plane or TCP data that we're trying to carry over any kind of trunks, because typically those systems tend to kind of max out MTU anyway. So there may need to be some back pressure to actually reduce MTU or use standard fragmentation methods if we come across that. Anyway, that's a quick summary of the data plane where we've got to. Now I need to just grab a breath while we jump into the control plane. So we've looked at data plane, here's the control plane. So a few principles that we agreed on the control plane as we're working through. First of all, each campus has to have its autonomy and security. So what we cannot have is a control plane mechanism where, someone in one facility can just see everything in another facility and control it, etc., etc. That there's a lot of risk there, and our kind of broadcast user input to the discussions as we were jumping into this control plane was saying, whatever happens, I cannot have my campus facility control plane compromised by another facility, wherever that is, even if it's one of my own facilities elsewhere as an organization, but obviously it could be a third-party facility as well. So there has to be security there. So we've got this concept where each facility is running, and again, probably nominally with an NMOS ISA4 registry. All the devices within those facilities have registered to that registry, and as far as the system is concerned, those campuses are autonomous. So we're in the thinking that we've been doing in the control plane, we're actually using the proxy / gateway, those purple boxes there, to actually be, if you like, proxy the interfaces that are seen by the other side. So if we want to send signals from one facility to another, the facility one sends them to that proxy gateway within facility one, and that's its job done. And similarly on campus 2, that facility 2 consuming that resource actually gets it as a proxy version from the gateway within its facility. So that's kind of a very, very high level summary of the concept. I'm now going to kind of dive in a bit, so hold your breath here because it gets a little bit more hairy. So, oh, that's interesting. I've actually lost some of this diagram. I think some arrows have horribly gone missing. So I apologize for that. I have no idea how that's happened. Anyway, let me try and explain it without some of the arrows. I don't know.
Andy, do you want to reset for a minute? Do you want to?
Well, oh no, this is why. Okay,
the old animation trick.
My friends had actually done it as an animation one. This is a slide that someone did for me. I'd forgotten it was animated. We're okay. I'm happy again. That's very good. So let me just unpack this and try and explain it as simply as I can. And I apologize because it's not that simple to understand, but hopefully we'll get there. So the concept here is we have a facility, which is the blue facility, and we have a facility, which is the green facility. And we have a WAN interconnect, which is what we're talking about in the 2110 over WAN. So from a simplistic perspective, if we don't think about the control plane, what we're doing is facility one is making some of the resources, the cameras, the microphones, the playback servers, whatever, available into the gateway in facility one. Those are being transported across the WAN and made available at gateway two, such that facility two can actually then use those resources. So that's what we're trying to achieve inherently. And I'm using one facility and another facility. Obviously, it could be a truck with a whole load of cameras at an event. It could be cloud infrastructure on one side. And in fact, this could be a federation of more than two facilities. So we could actually have a gateway, more than one gateway at a facility that's actually sharing resources with more than one other facility. But I've tried to reduce it within this example to the simplest elements so we can actually understand what's happening. And if you, again, just to unpack before we go too much further, so I've just described what happens at the data plane. You know, we're basically sending the essences via a gateway over a WAN using the data plane stuff we've talked about, then consuming them at the far end. Okay, that's pretty understandable. Each of those facilities, as I said in the previous slide, needs to have complete autonomy from a control plane. So we cannot have one facility taking control of the other facility. However, we want it to be as plug and play as possible. So there's some contention there in requirements, if you like. So the concept we have here, if I just talk you through the concept and then kind of unpack the flow of what needs to happen, is basically sender one gets connected using ISO 5 within facility one to receiver one, the virtual receiver on the gateway. So as far as facility one is concerned, when it sends a signal through to the other facility, it's sending it to the gateway. So the gateway is proxying, if you like, the receive nodes. It's a receiver. So when the ISO 4 makes a connection, it tells that receiver to tune into that sender. But that receiver is a virtual receiver, and all it's doing is proxying those flows over the WAN to the other gateway. So that's what's happening in facility one. If we jump over to the green side to facility two, then what's happening is, because that flow is available at gateway G2, we have virtual sender S3 there. That virtual sender has the source S1 available as a virtual source at the gateway there that the controller within facility 2 can make use of. So it can do an ISO 05 connection to receive it, to tell receiver R3 to connect to the virtual sender S3. So that's kind of a very high level unpacking of what happens in the control plane. Just to kind of unpack that a little bit more in terms of the steps. And I've got a slide that articulates this in text in a minute, but I just want to describe it as we're on this screen for just a minute here. First of all, for you to know as facility 2 what resources facility 1 has available, there has to be, and what we're currently calling an out of scope advertisement. Basically, facility 1 has to say to its trusted partners, which include facility 2 in this example, at some point in time it said, hey, I've got these 3 studio floors, they've each got 12 cameras, they've each got 24 microphones, and we've got 3 replay servers, blah, 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 blah. All of that stuff is, we've got 3 slow-mo machines, etc. And all of those things are available should you wish to use in facility 2. And of course, that could be another part of the same organization, or it could be these things being shared between organizations. But there has to be a trust by which, again, out of scope of this definition, facility 1 shares those with it. And that could be just a PDF of what them sharing by secure email with what they've got with their friendly facilities. Facility 2 similarly then needs to say, hey, I'm doing a production next Tuesday afternoon between 2 and 5. I actually need a studio floor. I need 12 cameras on it, and I need those 24 microphones, and I need one replay server, and I need a slow-mo. And it will actually ask for those bits, and a graphics machine, whatever else is needed. But basically, it can actually say, I need those bits. And so there can be a contract that's effectively agreed, and Facility 1 says, yeah, those resources are available, then I will book them for you and make them available to you at the time. So all of that stuff, we're kind of saying has happened in advance of the day of requirements, of the usage requirements, or typically a day in advance or more. So Facility 1 has actually said knows it's going to be loaning these resources or renting these resources to Facility 2. So on the day, what happens is, because it's got temporal information, it knows it's reserved those things for those days. Facility 1 controller actually says, okay, sender S1 and any of the other sources that it's making available, I will stitch them. I will do a connection via ISO5 to my gateway G1 on that day, and I'm going to do that. I've already agreed. I'm going to do that 2 hours in advance of the booking. So those services, all of those things are up and running, N hours ahead of time, and I stitch them to the gateway G1. So again, what's happening there, apart from that temporal execution of the connection, everything is standard NMOS in Facility 1. Jumping over to Facility 2, Facility 2 knows that those resources are going to be available. We've actually already given them, in the booking mechanism, effectively some virtual IDs, so it knows what those IDs are going to be as they're going to present on Gateway G2, those virtual versions of them. So Facility 2 actually says, okay, I'm going to request connections to those. Now, the proposal within the working group at the moment is the actual WAN connectivity isn't connected up for those resources until Facility 2 actually wants to use them, because the WAN bandwidth is precious. So Facility 1 has made them available to its own gateway, but until Facility 2 actually starts to want to consume them, they don't get stitched across the WAN. But basically, once Facility 2 gateway has actually had the request for the connection, it will actually get gateway G1 to actually instantiate those flows across the WAN. And then again, everything within Facility 2 is standard NMOS, because those sources are available, virtually available on Gateway G2, and it can stitch them up using ISO5 as standard in G2, in Facility 2. So that's the concept. Now, just to look at that in a different way, again, just to simplify it. So this is the, if you like, the registration. So this is the kind of the flow of them being available, and then this is the flow of them being consumed. I think possibly we don't need these other pictures now, because that first picture I shared with you is pretty all encompassing. What I've tried to do, and I've only put this together today, so I'm hoping this is reasonably summarizes this, but I'm just trying to illustrate the sequencing that I've been describing there, that we've talked through. So there's some stuff that happens ahead of time, which is Facility 1 tells its potential partners what stuff is available to be used. Facility 2, the user, the consumer, says, I would like to use these resources at this time. Facility 1 says, yes, they're available. I will make them available to you. That's the head of time negotiation. The at time execution is Facility 1 says, okay, I know that those cameras, those microphones, those whatevers are promised to the other facility at this time. So I will do my ISO5 connections of those to the virtual gateway. Facility 2 says, okay, the time has come. I actually need those flows. So I'm going to actually ask for connections to my gateway for the proxy versions of those. And the gateways then set up the required connections across the WAN, and we have the connectivity established. Now that's a real whistle-stop tour of what happens, because as you can imagine, under the lid of all that, there's lots of watchers. What happens if? And there's questions like, okay, what happens if one of the cameras fails in Facility 1? I'd actually reserved a spare camera, so I'd actually reserved 11 cameras when I only needed 10. But what we might, and basically Facility 1 would have stitched all 11 cameras to its gateway, but we were on the WAN. because we've only been consuming what we need. We've only stitched up and connected the 10 cameras we need. So we need to reconnect to the other camera that's actually not currently being consumed. So there's quite a few what ifs, which are the detail I don't want to dive into at this stage within this presentation. But hopefully that gives you some idea of the control plane sequencing. I've tried to summarize many hours worth of discussions from many clever people that have been contributing to this in just a few minutes here, but hopefully it gives you a flavor. And as I said, this is still work in progress. So we haven't finished yet locking in this control plane sequencing and the way we actually do it, but hopefully that unpacks it for you really well, or fairly well within there. So that is the story so far. There is still time to get involved because we haven't finished cementing this. If you're not part of VSF, then for goodness sake, why not? But we would love you to join, and we would love you to be contributing to this if you've got contributions to make. If you've got any further details you would like, do feel free to reach out to Bob, who's on this meeting, who's our secretary for VSF. He is contactable and knows everything about everything and who to speak to. My direct details are down there. There are many other learned friends that are part of this as well. So before I hand back to Wes for any Q&A, I just want to reiterate the invitation that when we're finally allowed to actually meet up face to face again, I would love to actually have a cup of tea with you. And if any of you in the UK, which is a lovely place to be, do come and ask me and we'll meet up and have a cup of tea. I'm actually hoping to fly on business for the first time this coming week. So that's going to be an interesting one after 6 months of being grounded. Anyway,
where are you going?
I'm going to Norway.
All right.
So they've got everything's very under control over there. So I think there's very little risk for me going that way. It's more as whether they'll still let me in from the UK. But I think we're reasonably clamped down on these things now. Anyway, that's a whistle stop tour from me. Are there any questions, Wes, or is there anything else you want to say?
So the first one came from Marco Silk. It says, as facilities must run autonomously, does the gateway have any reserving mechanism keeping the virtual source flows active and not switched away within the facility for their remote destination?
Okay, just trying to see if I understand that question completely. So just to talk about the assumptions we made, the assumption we made is the facility that's lending the resources, the lender, if you like, actually is stitching up those resources to its own gateway at the point that it knows they want to be consumed. The enabler for the WAN connectivity is the consuming facility in this diagram, the green one, actually requesting those resources be stitched up across the WAN from gateway G1 to G2. The one bit of debate we've been having in terms of those resources being available or not being available is how we actually handle the IDing, because when the original reservation is agreed, we've been describing the concept in the activity group of having reservation IDs such that those can be already in place on gateway G2 ahead of the actual connections being made available. So gateway G2 can be advertising the resources before they're actually stitched up across the WAN, and that's important because we're trying to retain and constrain WAN bandwidth whilst whilst actually allowing full control there. I don't know whether that actually answers the question.
Better to come off mute. Yeah, I think it does. So really what you're saying is that, let's say, for example, in Gateway 1, it's going to have those connections stitched up so that as soon as Gateway 2 tries to communicate with it, it will be able to access those resources instead of having to reconnect within Facility 1. Is that right?
Yes. Yeah. I'm just reading Mark's message again. I'll give a think on that, Marco. If you want to actually just ping me an email, I'll make sure I give you a full definitive description. So I also saw Thomas's
yes.
redundant gateways, virtual senders, receivers, and so on. So absolutely. So redundancy can be handled in a number of ways here. In fact, Wes has been a very good person within the activity group on prodding us on how we actually handle redundancy.
That's a nice way of putting it.
Yeah. Because we have several redundancy scenarios here, don't we? We have obviously connectivity redundancy. Now, we're assuming that most people in a WAN scenario like this are going to be probably using dual diverse paths with -7. Obviously, we're also assuming that if you want to have some degree of resilience, you'll have some resilience of gateways as well. So you won't just have one, but you'll probably have at least 2 gateways that you're actually running on. And as Wes has said, the actual resources that you're consuming, when you're doing a booking, there's an assumption that you would probably actually have some level of resilience and redundancy within the resources you're reserving to do that. So I think the ability to actually do those it exists on all of those layers. Really, what we've been trying to do here is make facility 1 run as a normal IP facility with NMOS, facility 2 run as a normal IP facility with NMOS. There's a couple of slight tweaks we've had to do that, certainly with the temporal reservation that needs to be executed on the sending facility. And apart from that, what the concept is, you have sufficient gateway resource, in brackets, including the redundancy you need, and possibly including the bandwidth you have on the WAN to allow you to do the level of redundancy you need. We're not trying, I think, we certainly haven't tried so far to actually create the letter of the law of this is exactly how it has to be. What we're very much trying to describe within the architectures in this activity group is a toolkit of resources. So you don't have to tunnel a data plane. You don't have to use FEC on the data plane. You don't even have to use 2022-7, but I would highly recommend you do. But in the control plane here, again, there are going to be some must-haves, and there are some bits here that we still haven't got as far as fully defining, but I think we have actually ironed out this architecture quite nicely in the last few weeks. So I feel like we're coming into land on this control plane architecture. So that's feeling quite comfortable. But if anybody out there that's listening today has actually thought of any gotchas that we may not have thought about, then I would absolutely love to get the input. This is an industry-wide solution, and I've just flipped out of my presentation completely there by getting too excited. So yeah, do feel free to contact me or Bob or Wes and give us your input, because we'd love to. We want this to be as all embracing and as all as encompassing as possible, while still finishing within a little while.
Okay. Yep. Do you have time for one more question?
Absolutely. Yep.
Okay. So this one's from Dave Chapini from Matrox. Can you comment on any need for additional security measures with content leaving facilities?
Yeah. Okay. So I'm hoping you were there at the beginning, but as I've been saying, security is all important here. Within the control plane, obviously, arguably, possibly slightly late, because the BCP 003 stuff in the control plane for NMOS has been something that was added after the other things were the other tenets of ISO 4 and 5 and 7 and 8 were defined. But the security is all important. Now, there is a question in the data plane, the actual media essence plane, depending on the kind of connectivity that's being used as to whether you need encryption of the media flows themselves. Now, we haven't addressed that yet, although interestingly, Wes and I were co-having this discussion yesterday about applying some of the learning and skill from one of the other activity groups into this for a future look at the securing the data plane for the media essences. One thing that absolutely is going to be nailed up from day one, and there is no getting away from it, is the control plane. So the control plane is going to be fully secured in this. And no matter what, most of the customers that I see on wide area networks are using what I call secure private wires that are provided by trusted service providers. So most of the solutions that I've been involved in today haven't necessitated encrypting the data plane over the wide area network, but we do absolutely embrace the fact that that's something we need to tackle. We've not been tackling it in this day one, but we are actually going to have the that as part of the next phase of what we look at.
Very good. Yeah, we have one more quick question if you want to address, and I don't think the group's talked about this, but this is a private question from our good friend Steve. What happens if you have facility 3 trying to talk to facility 2 and facility 2 talk to facility 1? We haven't really made an environment for that, but it's just something interesting.
Yeah. So what I would say is that actually what we have at least discussed the concept that facility 1 could be sharing the same resources with facility 3 as well.
Mm-hmm.
Now, obviously, if there's reverse path control like a PTZ, then or replay control on a server, then or remote aperture control on a camera, then there's some challenges if you're trying to broadcast it or multicast it rather than unicast it. But the principles we're defining here could work very well. The concept is, and it might be physically different, but you could conceive that facility 1 has gateway G3 there as well, another blue gateway, and it's entirely possible, because we're using multicast within each facility, that the ISO 05 messages connect up a number of cameras to gateway G1 and G2.
Mm-hmm.
Or sorry, and G3, G3
Yep.
on that side, and those then can be transported to multiple users, and there are quite a few use cases where we're seeing that, where some people are taking sort of the unilaterals as well as the multilateral feeds, and several people are doing parallel remote production on the same cameras and stuff. So there are scenarios that we see happening with that, but it's entirely possible within the constructs we've given. Yeah.
Well, I think that's a really great way to end it. We're trying to be flexible and everything like that. Andy, thank you so much for your time today.
Great. Thanks, everyone. Good to see you. Stay safe. Have a great weekend.